Okay, we still have 5 minutes to wait. Okay, I think everybody. Okay, okay. Yang I think ada kawan-kawan yang lama ramai juga. Okay, all kawan, Kelvin, Harry, Eman, Fitri, Brad Maria. Okay, thanks for coming. Nurawan, Wong Yitan, Wan Yitan. Okay, okay. I think I hope you all like my haircut. Okay, nice haircut. Okay, banyak pendek. Kalau if you got anything to say, or you can put in the chat room also. Welcome everybody. I think it's okay, ini adalah agenda yang kita. This is my training agenda for today. It's taking about 1 hour. It may be short to maybe 1.5 hours. Is there any Q&A or question asking? Okay. Certain topic like fiber history, actually I will talk very fast because other people may attend my fiber technology before. The fiber history will be quite similar. Okay, quite similar because it's talking about history. There are others. Actually, this training will be very much talking about do the design on the fiber to the home. The more important is the leading, the loss, fiber loss. How many fiber loss is allowed? How the fiber loss come? Where is problem? The more important, the other thing is the testing. How to come across on the testing procedure and to get the best testing result. Okay, and what is the common area that happen when we do the testing? I think that we capacity fiber it's not like the UTP. It's very simple. We put the tester come out training the test report pass or fail. But fiber report sometimes it don't come out pass and fail. It just give you the reading. Then you must understand the reading. And the testing also have a few testing. You have a OPN test and you got a level 4 test and we have the OTDR test. Actually more challenging actually is OTDR because OTDR always give you the different type reading and you need to analyze all the report. The OPM very straight to the point, either you get the reading or you don't get the reading, or very high or very low. Okay, I think it's without delay I will start my training. Okay, today it's welcome to our team. Welcome everybody. Mr. Daniel Wong, Eman Yat, Fitri, Harry Jing, Kelvin, Nurawan, Wong, and Wong Ki Yan. Okay, welcome. Now, okay, today training will be talking about the training agenda. First one, of course, fiber FTTH standard, fiber history, and FTTH outdoor design. Actually, it's okay. Then the indoor design and outdoor design, and the testing and some project photo for just for your information. Okay, this is my background. Okay, my name is Kwa Hai An. Okay, somebody will call me Kwa. Yang very good friend will call me Kwa Kari. Kwa kepala ikan, Kwa. Okay, because 1998 I was a sales manager for NIE. Of course, before that I was in different industry. Was in this genset industry in the Scott English, doing selling coming in genset. Then I changed my line to the IT line in the 1998. 1999, I was as a sales manager for Clipser System Integrated. Now no more called Clipser, now it's called Snyder. I've been inquired by the Snyder. 2001, I'll be regional manager for Nordet CDT. Nordet CDT actually is a spin-off company for Nortel Telecom from the Canada company. And after that, also being inquired by the Belden. Then 2004, in the 2004, I become country manager for Belden. And the regional manager, that means I look after Brunei, Malaysia, and these two countries. Okay. Then after that, when we come to Malaysia, then I will look after Malaysia and Brunei also, two countries. Become country manager for Belden, such Belden cabling. Okay, Belden, we have most of the world considered largest communication cable manufacturer. 2001, I joined the MTSB, MCMC cabling standard. That's why we come out the standard for Malaysia. We do the standard for the MTSB, FTTH standard, smart pool, broadcast, such a cabling. This is a member in the FTTH standard. Then you can see mobile, telecom, Gigabit also one of the committee member to draw the standard for fiber to the home. I'm one of the committee inside there. Okay, you can see my name is there. Okay, this is all the inside the standard there. You can see the standard in the standard there. Okay, basically I involve more on the standard. Okay, Evo. Before go there, I would like to try to share on the Evo. Actually, we are the distributor for the Evo product. Evo actually is Evo started in the telecommunication product. That means they start doing the 10-pair connection module, disconnection module, and the UI connector and the telephone faceplate. After that, they improve the product line through the structured cabling. Then they start doing the Cat5e, Cat6, fiber optic, and the total solution for the structured cabling. And they also, after they venture inside to the FTTH product also, then start doing the FTTH product. And they also do have a tools, and Evo also have the tools like the termination tools, UTP termination tools, and fiber termination tools. And you can see that all the tester is all Evo product. Besides that, we also have a wiring standard. Wiring, that means we got cable tie, labeling system, and this is a PG clamp. All is under Evo brand. Okay, Evo actually is a company from the Ezon Technology. Founded is 1997 in the Guilian, in the Taichung县, this means in the Taiwan. Okay, this is the FTTH product for the Evo product by Telecom. Just share. This is all the product we attend for until 2022 September. Okay, this is all. Then we have a series approval also. Even the Cat6 cable for we have a series Cat6 cable for Evo also have a series approval. Okay, then this is a project reference we have for the fiber to the home. Then we got 2006 unit, 1005 unit condominium, apartment, terrace house, and the terrace, okay, bungalow, terrace, factory, short lot, UOA. This is all our project reference for the Harvey Normal also, the short lot and factory. Okay, now that is our recommendation on our background. Now, when come to the fiber technology, and when we talk about structured cabling, it's very referred to the EIA TRA standard 568C. And when you're talking about ISO standard, it's 11801. But when it comes to the fiber, actually we very much refer to this ITU standard. Okay. Then we do have a Another standard we refer is the technical standard for in-building fiber. When start on 2009 and 2016, we have a new version. It's a standard for the in-building. We then upgrade to the new version 2016. And we have a fixed network infrastructure also launching simple deployment property under 2016. And basic civil works general 2020, we got another standard. Now we are working on the general requirement, micro trend, and the horizontal. This is all the standard I will involve inside there also. Okay, this is a MTSB standard. You can go to MTSB, download all the standard from the Malaysia for the fiber to the home, for the all the SMA TV, we call broadcast system, and almost all the standard you can get it from the MTSB website. Okay, now we go to the fiber history. Actually, fiber history we started is the year on about concept actually start very much early when the 1980 they can't start the experience when the light can transmit through the water. So you can see, then the light can transfer inside the pipe. That is a concept when the light can go through the piping, okay, through the water glass. Okay, that is a concept. When the fiber history, we start 1960. Actually, they do have a fiber is transmit talking 1000 dB per km. When technology improve, they are talking about 20 dB per km. And 1980, they are talking, okay, when the 20 dB km is talking about the loss for the fiber, the improve on the loss of fiber. When come to the 1980, we are talking about 34 to 45 megabit per second. That means it's talking about the speed for the fiber to carry at the 850 nanometer. When you see the 850 nanometer, then this fiber is transmit on the multi-move. Okay, when the second phase technology, fiber in the late 1970, fiber will be improved to 1 dB per km over 1003 nanometer. Third phase, the fiber history is 1979, improved to 0.5 dB for 1003 nanometer. 1985 is talking about 4 gigabit or more than 100 km. It's on the lab test, okay? And the 1992 is confirmed fiber is running on the 2 gigabit to 10 gigabit. Okay, that is about the fiber history. Now, the fiber construction. The fiber construction, you can see the fiber construction, we have the three main things. Actually, is the core size and the grading. Okay, in the fiber, we have two types of fiber. We always say multi-move or single move. Now, of course, for the fiber to the home or GPON solution, basically it's all totally go for the single move fiber. No more multi-move. It's all single move fiber. Multi-move fiber is only used in the enterprise network and maybe others industrial. When come to the GPON or come to FTTH, all using single move fiber. Okay, single move fiber, the core size is very small. It's 8/125 nanometer. Okay, nanometer, that means it's a 8/1000 mm. That means it's very small. And the human hair, rambut manusia, is talking about 60 micron. That means 8 micron tu about 5 to 6 times lagi halus daripada rambut manusia. Okay, then of course the cladding is outside side. Actually, it's talking about 125. Okay, then we have, you can see the multi-mode, they got a 50 micron and 62.5. If a 62.5 micron punya, maksudnya, that means that the fiber actually is a OM1 fiber, is a overlap fiber. Now most all the multi-mode fiber stay on the 50 micron. But today we don't talk about the multi-mode, we only emphasize on the single mode fiber. And the light will transfer through the fiberglass inside there. in the middle there. Like when you see the fiberglass cylinder like that, they bound, that one is multi-mode, is using LED. But single mode, they are using laser. They will go straight. Okay, I think understand when we talk about fiber to the home, the fiber using is a single mode fiber. Okay, single mode fiber, they are using laser source, and the fiber, the size is very small. It's only about 8 or 9.3. Okay, either 8 they use 8 or they use 9.3 micron. Okay, now element in the FTTH. When we come to the fiber to the home, there have few elements inside the design. First thing is OLT. Okay, it's optical light terminal. That's where the light source transfer. Okay, the source. Then we have ODF. ODF is the optical distributor frame. It's where all the fiber collected at the one place. It's called ODF. And normally at this is placed in the MDF, main distributor frame there. And we got a fiber distribution cabinet. Just mean after the ODF, he will go to the outside cabinet. From the cabinet, he will go to the fiber termination pedestal or maybe fiber distribution box. And they go to the fiber distribution box. And after that, and then go to the fiber wall socket. That means this is an element in the fiber to the home for the outdoor. From the light source going into the fiber wall socket until the fiber wall socket. Okay. After that, we'll go to ONU. It's the optical network unit. Optical network unit only will convert the fiber signal to the electrical characteristic signal. That means you become our network point already. Become network point there. Okay, this is a few element we were in the FTTH system. Okay, this is how now when we come to the element there, then we of course we have a central office. Central office actually is maybe in the either telecom. Okay, either telecom maybe or this time their central office. All the OLT, the main source signal will come from the main office there. Because they got the ODF. Then from here, they consider E side. That's why they always say E side. Then from E side, then the fiber will go to the either 10 to 20 km, go to all the area, and we got the FDC, fiber distribution cabinet. From fiber distribution cabinet, we'll go to the FDP, the fiber pedestal. It's about 1 to 2 km. That's called D site, distribution site. Okay, we got the D site, 1 to 2 km. This is called access network. We call about either you go through overhead or either underground. Of course, Malaysia, we still very well managed. Okay, and we have and we try to do it more underground. Okay, then you can see the whole city, whole area become more niche. And only certain area, old area like the brownfield, we got no choice. They still have to go overhead. That means you can see the cable gantong, the FTP gantong tak itu telephone tiang. That's one have to go for overhead. But for the new project and new development now, with all the developer, we try to put it underground. Then we use pedestal or we use fiber. We use pedestal. That means you don't see the cable hanging where. Unlikely you can see like Thailand, Vietnam, I think this India also same thing. All is under overhead. You can see the jalan, you can see all the roadside there. You can see all the cable like rambut like that. Very messy. Okay, but Malaysia is still well maintained. Okay, we still consider very good. Okay, now we got after that we'll go to the FTP and go to the fiber wall socket. And this last mount is called internal wiring. Is this called internal wiring? and will reach to the, then firewall socket and ONU will consider customer premise, inside the customer premise. Okay, now this is the element we will start doing the FTTH design. We have to understand all these things. Okay, this element, what they do. Of course, for the consultant, we design, of course, we only from the FTP to the ONU. FTP, ADC, LDC is not under our scope, but we have to have the understanding. We want to know where the cable come from and how's the loss will contribute in between the D side and E side there. Okay, for the central office or exchange, E side is considered exchange side. This is the photo. You can see the exchange side. Then go to the ODF. Then go to the fiber distribution cabinet. This is from the E side. Okay, when the distribution side, you can see the fiber distribution cabinet will go to pedestal, or they will go to the pedestal. They got two types. One actually is this type, or the metal type. Okay, and satu lagi, the one is on the tiang there. Okay, on the tiang there. There's another side. This is called FTP, and after that we'll go to the FTP. Okay, this FTP, why we call it FTP? Is because this is for the condominium. Okay, and either you for those landed property, then you will go to the fiber termination box. If for the condominium, then you got a lot of fiber, they call FTP. Of course, this one inside in our field, not on the design field, on the design field. This is also considered ODF for the building, for ODF for the building. Okay, then we go to the either landed or those short lot. Then it will go maybe bigger box. Okay, this is the D side. And come to the internal wiring, we have the FTP, or we call inside the actually in the FTTH standard Malaysia MCMC, they call it FTP also. Okay, of course we will classify it also ODF. Then under the FTP like this, then we go to the fiber wall socket. Okay, fiber wall socket either you go to 2 port or go to 1 port. And actually for the new standard 2016 FTTH, they will require for the penthouse go for 4 port. For the short lot, if for your short lot, let's say 4-story short lot, those days we only put two port each floor. In fact, for the new standard, we require at least 4 port for each floor, because the short lot, they may be cut to the half, got 2 tenants. Got 2 tenants, they need 2 fiber wall socket. That means if you only got 1 fiber wall socket, that means you got enough to support the other tenant. That's why people yang sewa depan, sewa belakang tak ada dapat Wi-Fi. Cannot subscribe Unifi because fiber port not enough, especially for the short lot. Okay, that's why the new standard asking for 4 port for every floor. Okay, kalau if for the condominium, every house still using 1 port. But for go to penthouse, we also recommended go for maybe 4 port. Okay. Then you will go to the ONU. This ONU actually is a modem. Ia adalah modem. Modem lepas tu kita ada router. Only go to the router. Router will go to the port. Okay. Then normally you can see the modem from the TM have TM modem. Massive have massive punya modem, and time have a time modem. But you can see the modem for time and the massive and the telecom. Telecom will use the first port, massive will use the second port. Actually, because massive pun sewa fiber from the telecom juga. They use the same fiber also outside. Okay, that's why they quite similar. But now people also fighting price. Today massive offer harga ni, then besok telecom offer a price, unified offer price line pula. Okay, that is how the work. Okay, now in the GPON G984 GPON budget system, kita ada kelas A, kelas B, kelas C, kelas D, B plus and C plus. ODN loss minimum and maximum. Two additional industry will best practice follow B plus or C. In suggestion in this year, then display in the this is that's mean the loss maximum cannot more. They have a limitation on the loss when you use a class. Okay. Now actually now we are in between on the we are in the class B. Actually we are in the class B. Malaysia we still in the class B, and the loss is talking about 10 to 25 dB we allow. Okay. Now ISP requires minimum signal strength masses time 23.5 dB, and kalau time dia minta 21 dBm. Maksudnya signal strength from the exchange, the tester you plug into the fiber wall socket, the loss cannot more than 23.5 dB. Kalau time punya project, they don't allow more than 21. If they don't allow more than 21, that's mean kita minus okay, kita minus kita punya loss allowed by the FTTH. Let's say example 2.3 dB, 2.3 dB yang kita allow for the loss for the bungalow or for this condominium, 23.5. That means the fiber loss at the FTP there shall not more than 23.5 minus 23.5 minus 2.3 dB. That means the loss at the ODF there before go into the house, the loss should not more than 21.2. Kalau you 21.2, then you reach plus 22.3, then you still get minimum 23.5. But normally you can get about 18 to 16. Kalau 18, that means if let's say example, I use this tester to test at the incoming 18.79 plus 2.3, I still got 21. I got 21.21 dB, 21.09 dB. That means I still got the margin on the 2 to 3 dB. But of course, for the design, we don't care how is the we don't know how is the strength, the signal strength from the D side. We have to make sure our inside the customer premise there, the loss should not more than 2.3. Then you are safe. If a signal at the D side there more than they're supposed to, then they will try to improve it. But we have to make sure our side no more than 2.3 dB. That is purpose for the standard design. Okay, this is just for your information. Okay, now in the GPON technology, the PON technology, GPON actually is a gigabit. We're talking about gigabit. Maybe PON system is a POM. It stands for the passive optical network system. What is a passive optical network? That means we distribute the system. We can use a passive distributor to distribute to many channels. Okay. when it comes to the before GPON system, we are talking about enterprise network. Enterprise network, when you need to dispute, you need to use active equipment. One floor, you want to dispute to 10 floor. Every floor you need to have the active equipment to dispute again to every point. But when it comes to the GPON solution, all the distribution point is a passive. You don't need power. That means you can save a lot those electricity, the maintenance job and the equipment cost at all the distribution side. And when it comes to the GPON system, they not just only carry the data. They to carry the triple play: data, video, and voice. Okay, that's why you have a PSTN, you got the internet, then you got CATV, then you got other services can carry over or changing to the OLT. From OLT go to the splitter, split to the every unit and go to the ONU. ONU be able to take out the signal and transfer to every house. This is a PON system. Now, bear in mind, every splitter have a loss. Okay, every splitter have a loss. That's why they have to calculate their loss on the splitter. They cannot split too many. Once they split too many, the loss will be higher. Then in the end, you don't get your 23.5 dB at the house. That's why they have to do the calculation. How many splitter they can use. Okay, now this is a GPON solution. Now it's talking about like the same thing also. Then you can see where every time we dispute, we split. If a 2.5 gig we split to 16 house, each house will get 150 megabit. The splitter not only will increase on the loss, but they will share on the bandwidth. That means if a 2.5 gig outlink, we transfer far to the 16 house, each house will get 150 megabit per second. Okay. If a 2.5 gig kita bahagi 32 rumah, setiap rumah boleh dapat 78 megabit per second. Because the GPON solution be able to dedicate. This means they can configure certain houses will get 100 meg, certain houses will get 2 meg, certain houses will get 20 meg, some will get 10 meg. That's why you all can, or let's say example, your house is a subscribe 100 meg. Now you want to increase to 300 meg. What they did at the OLT there, they got your ONU number, they know your ONU code, they can configure, and this ONU number give you 300 meg. Then your speed will increase to 300 meg. Okay, this is how the GPON solution can do. That means we can, you all can get require how many meg. Of course, if example you have 2.5 gig. If you have 2.5 gig, you got 16 houses. If 16 houses also require 300 meg, if not enough to supply one. But maybe some they still collect 300 meg money, but they don't give you 300 meg because too many people sharing. It may happen also. Okay, we don't know. Okay, especially at the very peak time, pukul 8 sampai pukul 10 malam, everybody on the internet. Maybe you can see you don't get 300 meg as you pay for. This is quite common. But this is quite common. But sometimes you can get, sometimes you don't get. Okay, this is why you always people say, hey, I bayar 300, I only dapat 100 meg. No, but this is happen because sometimes tak cukup nak share. Okay. Okay, now we've talked about ODN less the loss. Now we see we got so many element inside the outdoor. Okay, then we have a loss. Just now we say the D side, we got the E side, we got the D side, and we got a premise. Okay, D side berapa km? Masih still can remember? D side how many km? Anybody can tell me? How many km D side can go?
1 to 2 km.
Berapa? You can put in the chat room. You can put your you can put, boleh jawab D side berapa km? Tadi the gambar kata berapa km can go? D side D side, yeah, D side 1 to 2 km. How about E side? E side how many km? 20 km. Yes, good. No, good. You see now, and you can see okay. Now, if we got the E side, then we got the D side. We got how many km there? 20 km and 1 to 2 km. Then the fiber loss is 0.4 dB per km. Then you can see the loss already contribute. If a 20 km times 0.4, kita sudah 8 dB sudah hilang. Okay, and what is other loss you have? Connector loss. Connector loss is talking about 0.35 dB and or to 0.75 dB. That is connector loss will contribute in the ODN. Okay, then we got the splicing loss. It's talking about 0.1 dB or 0.3 dB loss. This another loss also contribute to the whole entire loss. And the splitter loss. Actually, yang paling banyak loss actually is from splitter. You can see the splitter loss 1 to 2, 3.5 dB. 1 to 4, 7 dB. 1 to 8, 10 dB. 1 to 16, 13 dB. 1 to 32, 16 dB. And 1 to 64, 20 dB. Sometimes the fiber is too short. Let's say the distance too short. Let's say example maybe certain project. I think last week I got one customer. Not FTTH unified, but actually it's an enterprise network. Because the fibers too strong, signal too strong, they have no choice. They use a splitter to bring. There are two ways to bring down the signal, the signal. I mean, increase the loss. Either you add the antennator. Antennator actually is like the connector. You plug in and plug out again. You plug in, then the other you put connector in between. That one will contribute 3 to 4 dB loss for the antennator. We call antennator to increase the attenuation, to not to be fiber too strong, the signal too strong. Or what they choose now, they take the 4-way splitter and they plug in. I think now they come back to me, maybe I think they solve their problem because the loss increased to 7 dB, at least not so strong. Okay, this is the loss contribute in the whole entire for the outdoor. That's why for the outdoor FTTH people design, they have to take this loss in the calculation, make sure the loss not more than maximum less than 23.5 dB. Of course, they have to make sure the house set inside still got 2.3 dB loss. Have to that means you reserve for inside building loss 2.3 dB. Okay, that's why sometimes we do the project, telecom people coming, they just plug in. Even the loss, maybe the loss inside the house is a 4 dB loss. It's higher than the standard allowed 2.3 dB. But telecom pergi, they go to the final fiber wall socket, they plug in 21 dB, still within the margin. They tak complain juga. Okay, they tak complain. So as long they got dB. But of course, for the project submission, we make sure the loss not more than 2.3. Okay, that one is a optional case lah. Okay, sometimes it happen. Okay, And this is a fiber splitter. Fiber splitter got few type. That means this is one in with the box, one in with the outside. This type, maybe with the cord outside. Okay, and the splitter technology. This is a splitter technology to share. They come from one fiber, they split 1 to 2, 2 to 4, 2 to 16. This is how they split. Okay. Now you can see this one. Now we see the telecom main exchange here. If the telecom main exchange here, then we see the fiber going to the each unit here, to the house there. From the fiber, go to the cabinet. Here got cabinet. Then go to the each house. Okay, we got 10 km fiber. Fiber exchange from the main exchange east side 10 km. Then they use 1.8 splitter. Then 20 meter reach to the condo. Then they use 1.16 splitter inside the building there at the MDF there. What is the loss? Okay. Now this is a scenario we share. Then we got the main exchange. Then we got 10 km fiber. Then reach to the cabinet, outdoor cabinet. We got splitter 1 to 8. 200 meter fiber go to the premise, and inside the premise got another 16 dB, 16 port splitter. Then the loss. Okay, now you can see the fiber loss 10 km is for 4 dB, 2 km is about 1.2 dB, 2 connector. Actually, the connector loss, when connector loss, we are talking about 0.75 dB times 2 connect 1.1. Actually, this type of loss, actually is a budget loss. The actual loss for connector maybe were less than 0.3 or 0.2. Okay, and the splitter, then the cable loss again, and you have splitter loss, then total loss is 31.28 dB. Okay, when it comes to the actual, this will be the loss. They do the calculation. Okay. Okay, you can see. Then this one we got a four-way splitter there. Okay, and a four-way splitter. If you take out the four-way splitter, then your loss will be the 28 dB. This means this will be the how they try to improve the loss dB loss there. Okay, this is how the calculation done. Or they change to the, if they want to go for the four-way splitter, then they cannot use 16 dB as a 16 splitter. They change to 8 splitter, then they can get 25.28 dB. Okay, then you can see the whole entire design. The splitter contribute the higher loss. That's why they have to play on the splitter side. Okay, this is of course consultant or maybe as a user also at we hardly go to touch this one. This is just for your information. This is basically exchange. I mean, telecom people will do their calculation. This just to share with you how the loss arrive. Okay, internal wiring 2.3 dB. Okay, that's why. Okay, now when come to the GPON solution, okay, I finished that one on the outdoor calculation just for your information. I hope this one will give you some idea how's the from the E go to D and go to the house, how the fiber loss happen. Okay, now and the GPON solution upstream is the 1.25 download is 2.5 dB, but now actually the migration will be going to 10G out and 10G down. Okay, future what they need to do is to upgrade their OLT system. When they upgrade the OLT system to the 10 gig, that means those days 2.5 gig can share about 16 people or 32 people. Now 10 gig can share to more people. That's why now future we hope once is the telecom or the ISP improve the 10 gig, then maybe that time your house you can require 1 gig instead of maximum 300 meg or 600 meg. You can ask for 1 gig. Easily you can get 1 gig for all the houses. Okay. 2.5 gig, if you have a splitter at the 1.8 plus 1.16, that means every house you only can get 19.5 megabit per second. If you're 10 gig, that means you can improve to 78. That means kalau if 1.8 8 times 816, that means 8 times 6 8 times 16. Okay, if 8 times 16, that means 8 splitter with a 16 splitter plus 16 splitter, that means one fiber module 2.5 gig will distribute to 128 houses. 128 houses, each house will get 19.5 megabit per second. If a 10G, 128 house, every house can get 78 megabit per second. Now, 380 units condo, how many core fibers shall come in? If they use 1.8 splitter, they need easily 48 core. If they use 16 splitter, they need 24 core fiber, which to the at least go to your unit 16, 24 core fiber. Okay, that will be any question. If any question you want to ask, you all can throw in the chat room there. Let me I will answer later. Okay. Now we already complete on the outdoor. Actually, outdoor the information given is just only the information, and now we need to design. Actually, basically we design inside the building. It's more to our scope. Okay, this is a MTSB guideline in the in-building fiber cabling for the high-speed broadband network. Okay, and we are changing the technology, the copper to the fiber solution. Okay, this is a copper to fiber evolution. Okay, that's where it will come in. Advertisement sekejap, Ibu. Okay, now dulu kita guna, we use the 600 pair, 1002 pair distribution panel. Then we go to lepas tu we have the 10 pair connection module, 10 pair, 30 pair, 50 pair, 100 pair, 200 pair. Fiber distribution. Sorry, not fiber. It's a copper, the telephone box. Okay, for telephone box Then we have a telephone cable go to the each telephone outlet. Okay, now we change from the telephone outlet, we change to the fiber wall socket. On the DB box, kita tukar kepada fiber distribution box, and then we change to the ODF. And the media, we use the telephone cable 2 pair, all change to the fiber cable. Actually, the component I'm saying is a media changing from the telephone cable to the fiber, from the electric characteristic to the light source. Okay, when it comes to the fiber, you have to, this is some construction you have to know. We have the indoor fiber, distribution fiber, we got the outdoor, and we got the area. Indoor fiber, basically you can see that we got on top there, the orange color. Orange color actually is a multi-mode fiber. It's OM2 fiber. If light blue color actually is the OM3 fiber. Also multi-mode fiber. When you see the blue color, when you see the yellow color, is a single mode fiber. That is a fiber we use for the FTTH solution and the GPON solution. And you see the last fiber, you can see the white color with the very 2.3 times 2. This is a fiber FTTH drop cable. Okay, this is the fiber drop cable. Basically also all single mode. It comes with a 2 core or 4 core. In the market, they also have 1 core. Okay, a certain project, then sometimes you go to the Shopee, Lazada, you say can buy the fiber very cheap. Actually, it's only 1 core, not 2 core. When it comes to the FTTH standard, we require 2 core. 1 core to use, 1 core for standby or backup. But in the market, they have a fiber, FTTH fiber like this design, but only 1 core inside there. That's why the price sometimes can be cheap. Then we have the outdoor fiber. Outdoor fiber will come with a different construction. The first one on top actually is a PE jacket. The second is with the PE. The second actually with PE with the cockroach armor. The third one actually is a steel wire armor. Steel wire armor actually they have a few type also. They got a single and double. Just this photo show is double steel armor, but we don't use steel wire armor in most of the construction project. But steel wire we basically use in the offshore project. Okay, basically we use the cockroach armor or we use PE. But sometimes certain project indoor fiber we are using cockroach armor with the low smoke horizon jacket because they want the rodent proof, tikus gigit. Sebab tikus selalu gigit itu fiber, that's why they want the better protection. They ask for the cockroach armor with the low smoke. Then we provide that fiber for them also. Okay, the other type fiber is area fiber yang untuk kita gantungkan fiber from the pool to pool, and that's called area fiber. Okay, the area fiber basically happen in the we call brown zone, not green zone project. Brown zone yang existing punya project lama-lama punya kita kena gantung fiber setiap ke rumah punya. Okay, that is called area fiber. That's why we got 3 type of construction of fiber. Fiber connector kita pun ada macam-macam fiber. We have a different type of fiber. Then we got the connector. This is a SC. Currently we are using SC connector for almost all the FTTH project. And we do have a LC connector. This LC connector basically used for the enterprise network or for the network switch. The other fiber ST. ST ni fiber pun connector also quite long time. It's replaced by the SC. Okay. No more people using ST. Kalau you still see ST, actually it's very old project. Then we got the FC. FC also widely used now in the telco project. Okay. Now you can see the ST and ST Singapore, Thailand and Finland, China. FC this connector quite similar, also bulat-bulat, tapi different. ST adalah click on, and the FC adalah screw tight. The ST connector very similar to BNC connector. If you are familiar with the BNC connector, the CCTV adalah twist on, twist in, twist punya, twist masuk dia ada spring loaded. FC line, FC dia adalah screw type punya. Then we do have the MTLJ. MTLJ also another connector for the structure cabling or for the enterprise network, but it comes with very short time after replaced by the LC. The concept on the MTLJ, the connector side is similar to the kita punya LJ45 punya side. The concept, then 2 fiber inside there. Then we have the SMA connector. This one for the industrial use. Okay, this is just for your information. Basically for FTTH we use SC connector. Okay, SC connector we come with 2 type also. All the connector come with the 2 type. They have the different type of polishing head. They got PC, UPC, and APC. You can see the color. If a beige color is a PC type. If a UPC is a ultra polish connector, ultra polish and angle polish stand for. Okay, if a PC is a beige color, you can see how the head look like. UPC adalah ultra polish, APC adalah angle polish. You can see the back reflection, negative back reflection. Kalau back reflection lagi tinggi, is better, is good, much good, especially for the very high speed transmission. Okay, in Malaysia, FTTH we are still using UPC connector. Okay, we're still using connector, but certain though like the splitter at the equipment side, they are using APC. APC, the connector, and you can see the connector. The connector is a green color. Then that will be the APC. Okay, this one must be be careful. APC dengan APC, you have to use APC connector meet each other. UPC with USB, kita tak boleh, we cannot use UPC one side, the APC one side. You will happen very high loss. Okay, that's why make sure UPC only can connect to UPC, APC connect to APC. Okay, this one when the side people must be very clear. Otherwise, once you plug in the wrongly, that means your loss will be very high. Okay, you can see what happened. APC to one end is APC, one end is UPC. Okay, then you can see if I plug in UPC to APC, you can, it's a well match. Okay. In the single mode fiber, also have a two category. One is OS2, one is OS1. Okay, and EITA standard we call ITU standard, so not EITA. ITU standard 652A and the 652C and D. In fact, you can see the loose tube and tight buffer. They are talking about tight buffer using OS1 is a 1 dB per km, and OS2 is using 0.4 dB. The transmission is talking about 2 km to 10 km. That's why outdoor basically all using OS2. But for your information, most of the fiber now use indoor or outdoor, all using OS2 fiber. Okay. Now the other thing will happen. Always come out in the spec. You can see the ITU standard 652A and versus 657A1. What is the difference? Actually, 657A1 actually is for the fiber which band sensitive fiber. You can bend the fiber. You can bend the fiber with a 7.5 mm, maybe 10 mm. The loss is very significant. If you're using ITU 652 fiber, you can bend 10 times on the cable diameter. Wait, check. Actually, why my camera hilang? Okay, now you see, now actually when we come to the terminate, come to the this installation, we are always talking 10 times of the cable diameter and 20 times of the cable diameter. When we pull cable, it's the 20 times of the cable diameter. This cable diameter is a 5 mm. That means 5 mm times 20. You make sure your cable bending should be 100 mm. When you do on the rest, it's not more than 10 mm. That means you can go for the 50 mm. Okay, this is a standard talking about pulling the cable and put the cable. But of course, we try all the fiber not more than 90 degree. We try minimize not more than 90 degree, then you'll be safe. Okay, when come to the 657A, that means you can bend the fiber more than the cable diameter. Okay, that means the loss is very significant. You're talking about 50 mm, you still can get 0.03 dB. The loss still only contribute to 0.03 dB loss only. Okay, this is a band sensitive cable. Now most of the PTL or the patch cord are using 657A, A1 or A2. Okay, number of core of fiber backbone. Okay, number of fiber core backbone, that means the fiber core standard is 2 core, 4 core, 6 core, 18 core, 12 core, 16, 24 core. This is a fiber. Of course, sometimes when we do the design, out of design, we need 30 core fiber. Of course, manufacturer don't produce 30 core, they produce 32 core. You have to use the 32 core or 36 core. When I see it put a color, the red color actually very common. Okay, 8 core, 12 core, 16 core, 24 core, 36 core, 48, 72 core. Very common fiber. Okay, very common in the basically most easy to get this fiber and the stock. Backbone minimum 2 core for each premises. Fiber termination board. Fiber termination board, it come with the 4 port, 8 port, 16 port, 24 port, 48 port, and 96 port. Okay. Termination, we got 2 core, we only terminate 1 core. But backbone, all the backbone we are asking to terminate all. But for the drop cable, we only terminate 1 core, but the backbone you have to terminate all the fiber. Okay, this is a single drilling. In the FTTH standard, we call single drilling. This is single drilling unit, either for the pole side or the underground. Then if a pole side, on the pole side, your network boundary will until the FTP. If underground, the boundary will be bigger. That means the developer have to taking care from the fiber DB until the fiber wall socket. For the short lock, this is a short lock design. I say that means now you can see this short lock. They got 3 story, ground floor, first floor, second floor. Each floor got 2 units. How many port FTP we have to use? We're supposed to use 12 port. You're supposed to use 12 port. That means we use 12 port FTP, but we don't have 12 port. Our standard is a 16 port. Then we go for 16 port. Then we go for 6 fiber wall socket. Okay, but because the new standard require for the short lock 4 port per house. That means you have to 6 cells, then you go for 24. In fact, the actual designs to go for 24 is still instead of 12 port. Okay, but the FTTH for the MTSP is recommended. Sometimes you propose 12 port or 16 port, telecom also approve. But for the MTSB, as such a design, we are asking for 24 port. Each unit 4 port. That means at least we can each unit at least maybe have a 2 tenant that can subscribe to Unify for future. If you only one unit short, one FTTH, if they cut to two tenant, that means only one tenant can get the unify the other tenant, no unify or no broadband services for them. And that's why the new standard will go for 4 port. This bear in mind. If you go for that, I hope you all can propose 4 port instead of 2 port. Okay. This is a FTP. This is a single dwelling unit, of course, and the MTSB. We are talking about the 2016. We are asking to pull the fiber from the FTP, leave the fiber inside the manhole. But chances like, and with the NCAT, that means the fiber must be protect with the NCAT. Tetapi then 10 meter coin drop cable inside the manhole. But so far I haven't seen any project do this one because when we submit to the telecom say no, tak payah, you just leave it to the FTP and the telecom people will pull the fiber until FTP. Okay, but of course, why the MTSB proposed for the fiber pre-fiber put inside there? Because we measure the trunking. We worry about future the trunking will be blocked. Then it's very difficult for ISP to pull the fiber through the trunking to the FTP. Okay, but this depends on your submission. Okay, pedestal and the pedestal maximum. You have to leave the space to 600 mm by 600 mm space for the pedestal P. That means you have to get ready the place. Either you don't need to install, but you have to, when you submission to the propose to the telecom, to the ISP, there got 2 chances will be happen. The ISP will ask you to supply the pedestal, or some ISP will ask you to put a space, certain height, then leave it the space, then they will install their pedestal. Depends on the area. Like the Negeri Sembilan, basically telecom will ask the developer to supply the pedestal. But certain area like the Selangor, you only to get the space. Pedestal was supplied by this ISP. Okay. Multi-dwelling unit. Multi-dwelling unit is like the condo. This is a condo multi-dwelling unit. Just to share this one, I think. Okay. Fiber type. Inside the fiber backbone and vertical backbone, they're allowed to use 652D. Vertical, they allow you to use 652D or I657. But for the horizontal cable and the drop cable, must use 657A. That's why now most of the manufacturer or supplier for the fiber to the home, they are all using 65A7 fiber spec. Okay. And in your tender spec, you also can asking to either you want 652 or 6157. Of course, you can ask for 657. I think the price increase also very significant. I think you can go for all 657 now. Okay, this is a design. Okay, now it's about 3 o'clock. I think I already take most of the time. I will try to speed up. This is one of the design allowed. That means you have the every floor you got the 8 unit houses. If 8 unit houses, you need 16 core, 16 port. That means every floor got 16 port FTP. For FTP, you pull 2 core fiber to the every unit, 2 core fiber, but you terminate only 1 core. But for the backbone side, you got 12 floor times 16. You got 192 core at the main FTP there. Okay, this is one of the design recommended. Okay, high capacity, and you got the middle capacity. They allow you to do also, instead of every floor, you can combine 3 floor 1 FTP, 3 floor 1 FTP, and 3 floor 1 FTP. In the end, you still 192 core, but you already cut down a lot. Instead of 12 unit FTP 16 port, maybe 16 times 3. You got 4 unit, 48 port. Okay, costing wise, you save on the FTP, but you may pull the longer cable from the second floor go to the third floor, fourth floor go to the third floor. That is an additional fiber you have to pull. The third thing actually is a maintenance job and the future maintenance job. The future maintenance job, the system you must have very good record there to tell which unit, which floor the FTP located at where. If every floor, then you know will straight away go to the riser there. But when it comes to this side design, you have to know this floor is either FTP on the top or FTP on the bottom there, bottom floor. You don't know, but you need to proper record. But in the end, it still contribute to 192 core, same core, so the same termination you have to do also. Okay. Okay. This one just now I missed this one. This one is what they did is they use 96 core fiber. 96 core fiber. The operation, they pull out the 16 core, go to the second floor. Pull out the 16 core, go to the third floor. Pull out the 16 core, go to the second floor. Single 96 core. That means they have to 192 divide 96. That means they have two fiber, two number of fiber. Okay, but this design is a 48 core fiber go to 48 port, or you have the every 16 core go to every floor. This one also go back to costing. Okay, costing wise, and now the market also chose either they go for pre-term fiber, pre-terminate fiber. That means the fiber already pre-terminate 16 core station ready from the manufacturer. What you have to do, you just plug into the ODF and you just plug into the FTP. No termination aside. But the challenging is a cable length. You make sure the cable length is cannot be too short or too much. Too much you have to find a place to keep the fiber. Okay, the FTP is still okay. Okay, but now the people also thinking about the drop cable instead of terminate, also get factory terminate 60 meter, 80 meter, 20 meter, 22 meter, 21 meter, 23 meter, and straight away plug to the fiber wall socket to the FTP. Okay, that will be the trend. Okay, just okay. Time I'm asking. Soho unit provide 4 port or 2 port? Soho unit actually you provide 2 port will do, because Soho unit very small unit. Only the penthouse we're asking for the 4 port. Penthouse only. And penthouse or the business unit. But for the house still 2 port. Okay, I hope office we propose. Office depends. Office if a multi, what type of office? If a 4-story office, 2-story office, we are go for the 4 port. But you're talking about office like the multi-story office, 20 or 40 floor office. Every unit only have a small office. Then 2 port enough. Unless the office space very big, that means you have to go for more 4 port. But of course, when this type of design is very depends on the, because sometimes the one company will occupy the whole floor. One occupy, but some occupy the whole floor. Whole floor, actually we design the whole floor maybe for the 10 unit office, but in the end, one office occupy the whole floor. They only use one, maybe two core, 4 core fiber, and we have a very a lot extra fiber there. Okay, but this one for the future. Maybe after they already move out, the other tenant coming might take second floor or third floor, take the take 30% or 40%. You still remain the this fiber port. But sometimes the design for the office lot, if you only pre-cast on the every unit, or certain design on the office is a open space. Only when the tenant come in, they will put their office design. In fact, this kind of design, we may not need to put fiber wall socket. If this design, you have to make sure you got sufficient fiber at the FTP. Only they do the renovation, they will pull the fiber from the riser, go to the each unit. Because we do have a project. After the tenant come in, they remove all the fiber wall socket because they only need they do the renovation for the whole floor. All will be different. Then all the fiber 2 core take out, fiber wall socket take out because they only need maybe 2 services instead of 10 fiber wall socket there. Or this will happen. This depend on the building design also. Okay. For the office, I think 5G we need to talk about the 5G. 5G we will talk later. Okay, let me finish this one. Otherwise I cannot finish this one. I'm supposed to finish in 1 hour's time. Okay. Okay. This is a design for the fiber. You can think about it. Okay. Now you can see the pre-terminate vertical fiber also in the what is advantage because low loss and the time saving, save cost. Disadvantages is need to get the actual length. Okay, you can start consider on this type solution. Then because it's a cost will be much lower, but it depends also. When you got very we did do the some calculation. If a floor reach to certain floor, that means you got 20 floor, you go for this type of fiber will be cheaper. Then you go if a floor below or above certain floor, then the cost quite similar for site termination and this pre-term. Okay, it depends on the situation also. But basically, it will be cost saving because time saving. You don't need to at the site you still can get. Okay, calculation on the vertical fiber. Now we say normal number of minimum core per unit is a 2 core. Then we have to plus 30% for the unit. 30% for the unit in the building. Example, we got 100 unit. You got 200 core, you plus 30%, that means you need 230 core for the backbone fiber. That is recommended by the MCMC or MTSB, MCMC standard. Okay. This is some test no? Because we run out of time. I don't do the test. You just this is we have a condo, 35 units, 35 story, 5 short lot, 1 multiple hall, 1 management office. 1 to 6 floor is a car park. Okay. 7 to 25 is every unit 10 unit per floor. 26 to 33 is 8 unit. That means 35 to 34 is a 4 unit double story penthouse. Now, if I have this design thrown to you, you have to come back to me. What is your design? Okay, this is a test I do. Of course, I hope I think I also not preparing for the offline training. Offline training just means you have to come to my office. Of course, I limited to 10% only because my room can occupy about 25%, but we only take 50%, 10%, and offline you have to answer the question straight away, do the design. We will teach you, and you have to do the design at the same at same day. Okay, but because offline we short of time, we online we short of time, we cannot do same time. Just to give some question, you're throw to you, you can snapshot, you can snap it and do it later. Okay, and if kalau siapa rajin can pass a question answer to me, I will. Those people take do this. You want to try your understanding on the design, do the calculation. Please, if you use a PC, you can snap it there. If you use a handphone, print screen it. Sudah, after you done your design, send to me. We got my group number there. WhatsApp you receive, you send your answer there. I will reply you and tell you whether correct or not. And I'll give you some example question how they did. At least you can learn. So those who really want to learn, take the exercise. Okay, take this exercise as your homework, please. Okay, take this exercise homework. Submit the answer in the test. Okay. Now this is a FTP 808 or 1616. This is just for information. For the fiber, we have a core. Inside, when the fiber, we do the fiber termination, we have to follow the fiber color code. The first color must be blue, orange, green, brown, / white. Red, black, yellow, violet, rosy, and this blue, light blue color. When we do the fiber splicing termination, we have to arrange the color code accordingly, because when at the bottom and on the top you must have the number 1 must be the blue color, number 2 must be orange color, number 3 must be green color. We cannot say simply change the number, that means you cannot get the right port in the end. Okay, you're facing a lot of problem with the testing and do the maintenance job. This is a standard color code for the fiber. Fiber termination, we have a few types of fiber termination. We got the polishing termination, we have a fast connector, we got the mechanical splicing and the fusion splicing. Okay. Now, polishing termination, I mean, this termination polishing is we need to polish the fiber. Actually, this is the old type, nobody use already lah. But I still using this one for the plastic fiber. When we do the project for the industrial plastic fiber, we still using the polishing type. Okay. Then now basically we use fast connector, plug in the fiber, click on, or just click will do. And mechanical splicing, there's still people using, and fusion splicing will use most in this project or FTTH project. This is a fiber wall socket installation. This is just for the sample. Okay, I show you how's the Evo fast connector. This type of connector, in the market, fast connector got two types. Okay, one of the fast connector, why my camera always auto off one? Okay, one of the connector actually is inside the fiber on the head there. They already have the pre-polished fiber. Pre-polished fiber, the fiber already pre-polished. What you have to do is you put your fiber go in. Two fiber will join inside there. Mechanical splicing mechanical inside there. Then click on. hold the fiber. That is called pre-polished fiber. And they have another connector. They have another connector. Is inside there. This connector inside there no pre-polished fiber. That means you have to pull through the fiber. Make sure the pull through the fiber. The fiber no joint inside there. It's one fiber come out straight away. Okay, what is the advantage? What's the advantage of this type of fiber? This type of fiber connector. Now, this connector, this fiber connector, you can use because inside no pre-terminate fiber, pre-polished fiber, and no gel inside there, and you can use this connector more than as long as your fiber no fiber broken inside there, your fiber still can put through. You can use 10 times, 20 times, 30 times, 50 times. If the fiber is the pre-terminate fiber, pre-polished fiber, then they got the gel inside there, and the gel actually should, in fact, the gel to really to match the gap there. If the gel less, or you have a dirty dirt inside there blocking, then your loss will be very high. And this type of connector you only can use 1 time or 2 times. If the loss is high, you have to cut and throw. But this type of connector, no gel one, you can use many times. If you got problem at the side, what you have to do, you take out the fiber and redo and you use back. It will save a lot of cost. Okay, that's what I want to share how this fiber do. You can see how this fiber connection we do. Okay, just like you see, when they put the fiber, you can see the fiber got access. They got access, then they use a cap to pull it down. After pull it down, they tighten the fiber, they remove the key. After remove the key, because after you pull down, you remove the key, the fiber will hold. Then after you take out remove the cap, then okay, the fiber already inside there already. Okay, then this is how you do, and this connector you can use many times, many times. As long as no fiber broken inside there, you still can use. Then when you go to site maintenance, you can use many times. Okay, this is the mechanical splicing. The concept very same. That means 2 fiber meet together, Then after that they got the gel, the matching gel, they call index matching gel to minimize the losses. Okay, because the gel light dissipation is same like the fiber light dissipation, that's why they can fill in the space there. Okay, then we use is a 3M fiber block to do the termination. The loss actually is not talking about 0.3 dB loss only, guaranteed by 3M. Okay, and this is another more common. Actually, it's a fusion splicing. You can use a bit by machine, and the machine now it become very very cheap already. Those days we talk about buy the splicing machine 30,000, 40,000, now tak payah. Sekarang now the fiber splicing machine 6,000, 5,000 you can buy the one splicing machine only. Okay, and this splicing will melt the two fiber and join together. The loss actually is about 0.1 dB or 0.01 dB. It's very low loss. Okay, that's why you got 4 ways to do the termination. Now you can see the loss budget. This is the loss budget for the fiber. Fiber loss still 0.4 dB. Fusion splicing is 0.1 dB. Mechanical is 0.3 allowed. And the factory terminated SP connector is 0.2. One pair fast connector is 0.4. Okay, SOC is 0.3 dB. This is not allowed for the NT. That's why you can see page 55. Version 1, page 55. Loss budget for the SDU unit, for the unit landed property, terrace house bungalow, the loss allowed is 1.6 dB per km. 1.6 dB per rumah. Satu rumah, no, cannot more than 1.6 dB for the landed property. For the MDU, condominium, apartment, the loss not more than 2.3 dB per unit. Okay, that should be the loss allowed for the FTTH for the condo dengan landed property. And when come to the ODU masuk ke rumah, go into the house. Normally, if you are design, you are consultant or you are the user, you design, there will be the 4 port. If a Unify, it will come with the 4 port. 1 port they will use for the red color actually used for the HIP TV. Then you still got left 3 port. Then 3 port is for the data. You can plug into your computer, plug into your IP, plug into your TV or other services, other maybe CCTV services. Okay, and of course you got the Wi-Fi. Okay. For the houses, for the certain like the bungalow house or anything, if you have many cable come from the, you got a Cat6 cable or Cat5e cable come from different room or different place, you want to collect in one place, and you can consider Soho box. If like the condominium, like the Soho, like the Soho just now, you may not need the, because you only got 1 port, no need Soho box. This one only for those unit you got many 2-3 port Cat5e cable or Cat6 cable come back to one place. You need to house it, then you can use the Soho box. This is a ODF installation that to share. Okay, when it comes to the ODF room preparation, make sure all the room preparation telecom will request for the cable tray like this one. Okay, you have to prepare for it, and the aircon, and the split. Another one is you have to put a split power meter. That means power meter ni ada, you have to at the ODF room there must have the split power meter. That means TMV meter lah. TMV meter must ada kena asing satu TMV meter, because after the 2 years they transfer the whole building to the JMB, telecom will take over this room, because telecom will who will pay for the electricity. If the telecom take over the room, telecom will pay for it maybe. Okay, That's why they want to split. The telecom will manage the whole thing. That means they need a split power. If we're under telecom lah. Okay. Testing. Now we go for the testing. We got few ways to do the testing. We got VFR, power meter, level 3 or level 4 tester, and the OTDR. Okay, when we use just now I'm talking about wavelength, 850 nanometer, 1003 nanometer, 1005. That one is a wavelength, and when come to the UV wavelength and visible light, actually is below 850. That's why kita cakap, don't always look at see the fiber source from the ONU or anything, because when come more than the 800 that time human eye manusia punya mata tak boleh tengok dah. We cannot see the light source already. That one will damage your eye. That's why we see. Don't sekali-kali tengok, because no point you can see. Only the UV light and the certain light like less than 650 you boleh tengok. Let's say example like this. This is a laser. You can see the laser light and LED light. We can see by the human eye is less than the 850 nanometer. The visual field locator, the nanometer they use is about 650. 650 only you can see. Okay. Now, okay, this is a visual field locator. What is it using? We plug into one end. You can check which port is to come out from which port. If the light source never come out from that port, maybe the fiber already broken in between. If broken in between, you can see the nampak fiber light source come out from the fiber, then you know the fiber sudah putus kat situ dah. The fiber lock will mean broken there. This is using light source. The first two will do the testing. We use the VFR. You can see nampak side there. Fiber tak ada light source. We see again. Nampak sini. Then you can see. Then fiber broken there. Okay. If we are using OPI meter, same thing. The loss, just now we say the loss is about 1.6 to 2.3 for the different type of. Okay. Now, when you use the OPI meter, you have to set reference. How to do the set reference? That means you need 2 patch cord. Then you put 1 coupler, 1 light source, and 1 meter. After you set the meter, you have to zero the loss. You will get the loss as a maybe 0.24 dB for 2 patch cord. Because this 2 patch cord, see my mouse now you can see these 2 patch cord. This patch cord will contribute loss also. This patch cord also contribute loss. In order to get the actual loss for the entire building we want to test, we have to take out the loss on the patch cord. How to take out the loss of patch cord? That means you put the 2 patch cord together with 1 adapter. After that, you will get the loss maybe 1.2 dB. Then you use the tester must be able to zero that means we say we can cipher the loss, they will become 0. Once they become 0, that means they take the tank as a reference. Then after that we unplug and we go to plug to the system. Plug to the fiber wall socket until to the ODF. The loss come out, then that will be the actual loss after we minus the reference for the patch cord. Okay, now after that you see we plug in, then we can test. You will get the dB, then that will be the loss for the actual loss. Okay, now this is an example. Now we have a tester, we put in the light source, then you go to the meter there, then you can test from the ODF, to the FWS, from ODF go to the FTP to FWS, you can see the loss, they will come out the actual loss. That will be actual loss. But the disadvantage on the OPI meter is what? You have to record, you cannot save. But certain tester can save. But there's certain tester that you can save the record, but the save is only 1, 2, 3, 4. You still have to do the record. That means one is for which unit, second is for unit, third is for which unit. But for the troubleshooting now, in fact, for the telecom come to do the inspection, those days, telecom they will ask for the OTDR, but some now telecom they will ask for OPN to test, because OPN will give you the actual loss for the whole entire unit. And for my team, when my team do the installation job for the project, in fact we do 2 tests. Firstly, we use OPM test. After that, only followed by the OTDR test. Because OTDR we need to submit, but for OPM test, when we pass this OPM test, we know definitely will pass the OTDR test. Okay, this is some sample on the loss. Okay, test report. But this is more basic. After we do, we will key into the PC and come out a report from that. That means which floor, which unit this loss will be. This is a proposed test report for the OPM. Level 3 test report. Level 3 test report, this is another tester, but this tester is very expensive. It will cost you about, OPM meter and light source will cost you about, if the light source more expensive, light source will cost you about $600 to $700, OPM will cost you about $100 to $200. Less than 1,000 you can get one set of the OPM and the light source. But this level 3 tester, line tester, this is for structure cabling line tester, but we also can use it to test for the FTTH. But he will give you the good loss, the good report. You can see the report for the one port to the other port. They will take out the loss, the reference also. They will tell you what is the length. This tester will can tell you berapa panjang fiber and what is the loss for the 1310 and 1550. Okay, you can see the report very good and pass and fail. But this tester will cost you easily 90,000. Okay, 90,000. Okay, so that's why I think not many people will use this tester lah. Okay, and the last test we use is the OTDR. Now you can see actually this is a copy taken from the MSB Standard report. Now they have two things. You have, when you do the testing, make sure the contractor will do. First thing is the damming fiber. Second is the damming fiber. You have a 100 meter damming fiber and you have a 10 meter damming fiber. These two things you need for the FTTH OTDR test. Okay, because for the certain project like the landed or maybe the condo, the fiber too short. Actually, OTDR is very good for the long cable. If you're too short, they cannot give you a very good measurement reading. In order to get the measurement reading, you have to put a damming fiber we call launch fiber. It's good for 200 meter launch fiber. Then the tester will start calculate after the launch cable. Then you can get very good reading. And the end, you need another damming fiber at the fiber wall socket. If you do the launch cable without the 10 meter launch fiber wall socket, what will happen? The test report will come out FTP loss. After FTP loss, the FTP loss, fiber wall socket, the last connector here, the loss not calculated. Okay, bear in mind, if you without the 10 meter, your reading is only until 1, 2, 3 FTP. The last fiber connector is not calculated. If the last fiber connector it doesn't fail, the result will tell you pass also, because they don't calculate the last connector, because the last connector, when come to the last, the light already burst already, not the OTDR unable to test the last connector, because in the end the light already burst out. That's why you need to another 10 meter patch cord or dump cable to get the last connector loss. That only can protect your, of course, if you don't do that, you will get passed, but in the end, telecom people coming and test if last connector got problem, you still have to go back and redo again. That means it will give you much more maintenance issue. Okay, that's why I propose to the contractor or the maybe consultant do the testing, make sure if you use OTDR, put 10 meter in at the fiber wall socket there. Okay, then you need 10 meter, you use the tester, you test, then you need 10 meter patch cord at the end. This will be the proper test recommended. How to set up OTDR? You need either old time or real time. You set 1003 or 1550 or both. For faster, you use 1310, or for both 1550. 1550, yeah, you put 150. 150 is very good for the band sensitive fiber, when you are very sensitive on the band. That's why you can give you very accurate loss on the 1550. Okay, but of course, and the range actually is good for the 100 meter above lah. If you don't have, you have to use launch cable. The pulse rate is a 3 nanosecond, 5 nanosecond, or 10 nanosecond. If your cable short, you use for 3, and maybe 5 or 10. Don't go for 20 or 30, because your fiber is very short length. Short. That's why it's short length, not the long length. You don't need to go for too high pulse width. And they will tell you the pulse width. You can see. If I fiber 500 meter, you use 5 nano, maximum 20. Okay, if for 10 km, you can use until 100 nanometer. This is about guideline for you to set the pulse rate width. In the OTDR report, he will tell you few things. Either the cable for launch cable, they got the connector inside there. They got the how many splicing, and when is the end. Then what is cable length? Okay, you can see the symbol. I will show you the symbol. You can see the trace here. The cable loss berapa? What is the loss? 0.1 dB at the first connector. 2 splicing. 1 splicing 0.1 dB. Second splicing 0.1 dB. The event number 5, you have another quarter 0. Another connector loss is 1 dB. Total is 0.6 dB loss. This will be OTDR report. This will be the symbol. This is a launch cable, starting point, cable loss, connector loss, splicing loss, end point. You can from the symbol you can see, loss for the every event. If you don't see the event, then you can go to see the graph. This is how the graph look like. Okay, the graph look like show you when the connector loss. When the connector loss, you can see the light always got the misty other light source lights, but connector and connector mesh together somehow the light will ada leaking ke, the light akan keluar sikit, lepas tu dia turun balik. That is a loss on the connector. When the splicing loss, they can see straight away they go down. They don't have a light burst out. That's its connector loss. And come to the end, you can see the light like naik turun banyak. That one should be in the end of the test already. That will be the graph this loss. Of course, they got a distance. Okay, of course, because on the line I can't do the too detail. I hope if you all like it, you can join the training for the next training I have is only 10%. That one is a hands-on training for those contractor or for any people who like to learn how to do the fiber fast connector termination, splicing, mechanical splicing, and the fusion splicing. These type of the three type of termination I will teach you all. Okay, how to do? Is only I allow 10%. Each person I will charge $80 because all the fast connector, all the this mechanical itu Laguna is I have to throw. You cannot use back. That one you then some fiber. That one I will charge because of that one and some ada makan juga lah. We give some break. Only that one we charge $80 only for 10%. Those interested one can join the training. At that time we can use OTDR to test, to learn. Easy for me to do experimentation and tell you to explain to you how to read the test report. Okay. This is the measurement loss. On the loss, maybe the gap actually is how many dB loss already. Okay. This is the labeling recommended by NTSB. This is a simple report for the unit, for the core and the losses. Okay. Labeling. We hope we strongly recommend do the good labeling for all the project. That is very important. Okay. And this is okay. Now I share some photo will be happen on the project on the workmanship issue. I show you all it got problem. You can see the cable kinking. The tarik cable macam gitu all the cable putus. Okay. Nah, cable siap cable buat kerja, they leave the cable and they just tight like that. They thought it's like the electrical cable. Macam electrical cable dia tight, lepas tu dia boleh gantung, tarik, gantung, tear ice. Okay. That will be happen in the site also. That's why sometimes we go to the job, we see, it's already completed. But before completed the job, you go to the site, see, you can see a lot of things happen like this one. Sometimes why the fiber loss is high? It's contributed by this type of workmanship. And macam ini, what is problem? This one is a cable installation. The fiber, the FTP terbalik lah. They suppose on top they install. Okay, this one also okay. When cable bending inside there also very be careful also. This one also will contribute. You can see cable already bent rosak kat situ because they don't have they should put some additional fiber protection there. Some we call tube cable, the fiber, the tube, the tubing. They put tubing to protect this steel. Can you see? Now this all cable come with when we do the fiber. Nampak sini fiber. We have to recommend after the fiber come out with the tube, because this fiber we cannot all go inside. That's why we have to split off and use the tube to go inside. And this one might be protected by the tube. There are a lot of projects that don't use a tube, they just go in like that. Then that's why they will damage the fiber. Okay, and the good ODF, they might have a two-side also cable management, and it's easy for them to put a patch cord. And this is a pedestal. We see the pedestal inside pedestal macam gitulah. Okay, inside is a FTP actually. Outside is like the pedestal. Inside is the FTP. Okay, this is another type pedestal. Inside is like this one. Okay, thank you. I think anything to ask question, you all can put your question. I think the 5G I will talk later. Let me discuss a bit later about 5G because now also quite hot topic about 5G. And yesterday somebody also talk about 5G to me. Actually 5G in the end 5G and its network actually is it's very much to the Wi-Fi concept also. That's why those days to our this broadband system, you can go for 5 km, 10 km. When it comes to 5G, the distance is talking about 200 meter, 100 to 200 meter. That's why we need a lot smart pool come out. We need a lot AP come out to support 5G, and we need a lot. Then it will become like outdoor fiber, outdoor Wi-Fi concept. Then you can go for the 5G connection. The 5G you need the line is about 200 meter, 200 meter to each point. Then you will see a lot those AP set up to support the 5G. Of course, the speed we're talking about 100 times of the current speed you have. Okay. Any question? Please go to my. I think we have go to the Facebook GW there and to share to add the like and share, because we have a new training and we will put inside there in case we miss out to WhatsApp to you.